USB charging cables explained. Safe and simple. Hi everyone, Leo Notenboom here for askleo.com. Here's a question I got the other day. So many devices come with only the charging cable and not the actual charger, plug/block itself, which has the label on it stating what voltage and amperage rating it has. I've yet to find charging cables that come with such labeling on them. So how do you know what that particular charging cable is capable of? Or are they all universal charging cables, whether or not they come with a plug? USB standardization has made all of this so much simpler. For the most part, if the cables fit, your device will charge safely. Slowly perhaps, but safely. There are exceptions, but when talking about portable devices, it's actually pretty rare. The older, larger square plug and socket for used is the USB-A socket. Regardless of what's at the other end of the USB cable, if one end is USB-A, that tells us pretty much everything we need to know. USB-A supports 5 volts. That's it. That's part of the definition of that particular version of the USB standard. Now, originally, USB-A ports were limited by that specification to providing only 1/2 of 1 amp of power, 0.5 amps or 500 milliamps. Though that's been increased in USB 3 to nearly twice that, 900 milliamps, and even 1.5 amps in some charging specific situations. But the upshot is that if your device uses a USB cable of any sort to charge, and that cable plugs into a USB-A connector, it'll work. The USB standard defines everything we care about. It may charge more slowly than it could, though, and that is where USB-C factors in. USB-C is the newer, smaller, more flexible version of the USB family of connectors. USB-C is smaller than USB-A. It's got more wire connections in it. Believe it or not, there are 24 in there as compared to the original 4. And it's symmetrical, meaning you can plug it in either way. You don't have to do that. Plug it once. That didn't work. Plug it in. Nope, that didn't work. Turn it over. Now, finally, the third time. USB-C is more flexible, but slightly more complicated solution for power delivery. It's not limited to 5 volts. USB-C may provide 5 volts, 9 volts, 15 volts, 20 volts. Later versions of the protocols involved have also expanded to include 28, 36, and 48 volts as part of what's called EPR, or Extended Power Range. Here's the trick. When you plug in a device, say your phone, into a USB-C socket, the phone and the power supply have what I like to call a little conversation. They talk to each other and they figure out what voltages the power supply can supply and what voltages the device can accept. They do a little negotiation. Now, if there's no conversation, then the default is our old friend, 5 volts. On the other hand, if the two can negotiate something better, then yeah, that's what they're going to use. And if that happens, your device will charge faster. Now, when it comes to your mobile phone and other small portable devices, a USB cable is just a USB cable. Wires in the connector at one end pass through the connector to the other. If you can plug it into a power supply at one end and your device at the other, then the cable will work and your device will charge. What I've just described are referred to as passive cables. They're just wires that connect things. They don't do anything other than that connect. However, some, maybe even most, USB-C cables actually have a little chip as part of the cable. Among other things, it identifies the cable's capabilities. For example, that extended power capability I talked about can range up to 240 watts of power delivery, which requires a cable capable of safely transferring that much power. What that means ultimately is that the conversation I just mentioned between the power supply and the device now includes a third voice, the cable connecting the two. The conversation amongst the three of them then covers what the power supply can supply, what the device can accept, and what the cable can handle. The goal then is for the three of them to then agree on the safest and highest power delivery. Now, as you pointed out, more and more devices are coming without a charger. In fact, I've got extra chargers here. What we're talking about here are these little brick type things. This one has folding out prongs. This is one that came with one of my other phones. You can see it's got a USB-A connector on there. Here's the issue. We're collecting them. I have probably about half a dozen of these things. We have so many devices that come with chargers. And then the chargers usually outlast the devices they came with. This one, I think, came with my third or fourth phone ago, right? So this is probably a good 10 or 15 years old. Now, given that USB chargers are the emerging standard, each device no longer really needs its own unique charger. The chargers we've already collected will do just fine. Assuming the cables fit and connect, you're mostly done. And if you find yourself short a charger, well, they're standard, they're inexpensive, and they're easy to find. USB has simplified the charging landscape dramatically. As long as you have a USB charger and cable that connect to your USB-compatible device, you're essentially done. You don't have to worry about volts and amps and all that other stuff we used to worry about. The only optimization you might consider is making sure that if your device uses USB-C, that you use a USB-C charger to take advantage of the potentially higher charging speeds. For updates, for comments, for links related to this topic and more, visit askleo.com/185688. I'm Leo Notenboom, and this is askleo.com. Thanks for watching.